Hi everyone, in these last few slides, let's talk about carbon-13 NMR spectroscopy. Okay, that's going to be a bit easier compared to the proton ones. Okay, so here the number of signals reflects the number of different kinds of carbons in a compound. And the chemical shift normally ranges over 220 ppm. But for the proton NMR, it's about maybe 0 to 15, but here it can go to 220 ppm. And in carbon-13 also, reference compound is TMS, trimethylsilane. These are approximate values of chemical shifts for carbon spectrums. We can refer to this table if you want to find out a specific type of a carbon where it appears in a carbon-13 NMR. So this one is carbon-13 NMR spectrum of 2-butanol. So you can see here there are 4 different carbons. So this is 3 hydrogens on this carbon, 1 hydrogen alcohol group and these groups on this D. C has 2 hydrogens and these 2 carbon groups. C has 3 methyl groups, which is different from this methyl group. So there are 4 different types of carbons. So then we would see 4 different carbon peaks. Okay, so the carbon A would be this peak, and then the carbon B, this methyl group is this group, and C would be this group, this peak, and D would be here because D is attached to oxygen, which is electron withdrawing group, oxygen. So similar to the chemical shift interpretation, we can also predict like where each carbon appears. Okay, and we call this spectrum as proton decoupled. That means we have not coupled the protons on the carbons. And this one is a proton coupled carbon-13 NMR spectrum of the same compound that we saw earlier. But here we can see if you have carbon A, there are 3 hydrogens on carbon. So carbon will split into 4. Again, we go by the n+1 rule, but the hydrogens on the same carbon. So 3 hydrogen, 3 plus 1, 4. So A carbon will be a quartet, right? And then you look at the B carbon. On this carbon also there are 3 hydrogens. It's going to couple with the protons. That's why it's called proton coupled. So B carbon also would be a quartet. And then the C. So the C carbon has 2 hydrogens on the carbon C, so that would be a triplet. Okay, and then the D carbon has 1 hydrogen on it, and that would be a doublet. And then close to 77 we can see 3 peaks together like that, and that is due to the reference compound trimethylsilane comes around 77. So this is the proton coupled proton NMR, and the previous one is proton decoupled. So here's a carbon-13 NMR spectrum of this compound. So we can see here these 3 hydrogens on this carbon would be one environment, and then you have these 3 groups. Methyl groups are 1, so that's B, and then you have this carbon C, and this is D. So we can see 4 peaks due to that. So this is for the peak A carbon, peak B carbon, peak C, peak D. Normally the quaternary carbons, meaning carbon with 4 carbons, we call it as a quaternary carbons, they give us a very small signal. Okay, so primary carbons would be a higher peak. So these are primary ones. Secondary, so these are primary A and B. D would be 2 carbon secondary, and this is a quaternary carbon. Okay, carbons that are not attached to hydrogens gives very small signals like this. So that's about carbon-13 spectrum. So we can conclude our chapter here.